In this video we are going to talk about scalars and vectors. Physical quantities can be scalars as well as vectors. Now what are scalars and what are vectors? There are some quantities like mass of an object or length of a, let's say this marker again, right? We just need to specify the magnitude of that. For example, 15 centimeter or mass of this marker is again 15 gram. So I don't have to specify any direction for that. Such physical quantities, they are called scalars. But then there are some physical quantities where you need to mention direction of that. For example, force or velocity of a body, or then displacement. Okay, now what is displacement? I'm at point A here. I travel about 50 meter towards east. Now this is my north. So I'm traveling 50 meter towards east. Now what I'm going to do is I'm going to travel 50 meter towards south. I travel 50 meter towards west, and finally I'm traveling 50 meter to north. Now what you see here is towards east 50 meter, south 50, west 50 and north 50. I have traveled a distance of 50 plus 50 plus 50 plus 50, that is 200 meter. But at the end of this whole thing, I am coming back to the same point A. I travel from A to B, then B to C, C to D, and back to A. I have walked 200 meter, but I am reaching the same point. So someone, at about 9 o'clock I was here, and again at 9:08 I am here. So someone saw me at 9 o'clock, and then he again saw me at 9 hours and 10 minutes. Okay, what he notices is that I am standing at the same place. Can he believe that I have walked 200 meter? The answer is no. But then someone who is watching me from 9 o'clock to 9:08, he knows that I have walked a distance of 200 meter. So my distance covered is 200 meter, but my displacement is 0. So now let us define distance. So distance is the length of path followed, correct? And my displacement is the shortest distance covered from initial to final position. Suppose I take my displacement, or if I start from A, I reach B and then I reach C, and I stop here. I am not going to towards D and then back to A. So in that case, my displacement would be from A to C. Actually I walked 50 plus 50, 100 meter, but the change in my initial change in my position, it is only from A to C, right? And then that is going to be equal to 50 root 2 meter. So it is not 100 meter, it is less than 100 meter, and that is what is displacement. So displacement is from A to C. The whole thing is distinguishing between distance and displacement, distinguishing between vectors and scalars. When I talk about the distance traveled, it is 200 meter and it happens to be a scalar quantity because I'm not specifying in which direction. Now for a distance of 200 meter, I can as well start from A to B, and my next distance covered would be let us say about 150 meter here from B to that some point P here, right? Over there I am walking a distance of 200 meter, but then here my displacement also in that case would be 200 meter, But in this case, my displacement from A to B to C to D and back to A, it is 0. So that is how vectors and scalar work. Now some examples of scalars are mass, time, temperature. Even current is a scalar quantity. We are talking about these fundamental physical quantities, but then quantities like pressure, energy, or work done, these are scalar quantities. But then on the other hand, I have force, I have displacement, then I have velocity. These are a few examples of vector quantities. In the next video, we are going to talk about vector additions, vector multiplications, and then some laws pertaining to that. Thank you so much.